Hello, everybody. My name is Yaro Rivera, and I'm a technical marketer at Epic Games, primarily focusing on the enterprise space. Thank you so much for joining my Unreal Fest session on visual fidelity with ray tracing. Today, we're going to cover several topics. We're going to look at project settings. We'll check out a couple of different lighting scenarios. We're going to talk about the hybrid ray tracer and how we can use that to balance visual fidelity versus performance. And we'll finish off taking a quick look at the new Render Manager. So thanks again for taking the time to watch this session. I hope you guys enjoy it. Let's jump in there and check it out. Cheers. All right, so this is the end result that we'll be working towards today. This is a project that I put together to launch the Automotive Material Pack, and we'll be using the automotive materials throughout this presentation. You can download the Automotive Material Pack from the marketplace, and it is revised with the engine, so make sure that you keep it current. The A5 Cabriolet was provided to us by Audi, and thank you so much to Audi for giving us your TrueCAD data. It's a real treat to get to work with such high quality assets. So let's go ahead and jump into the editor and start checking some stuff out. So the first thing that I want to talk about are some of the project specific settings that I always use, as well as some plugins that I'm using in this project, and one very important CVAR or console variable that you're always going to want to turn on right away. So let's go ahead and check out some of the plugins we're using by going to settings and bringing up the plugin editor. So I'm using the sun position calculator. It's actually what's lighting my scene currently. You can see it here if we select it in the viewport. We're also going to be using the HDRI backdrop. And the final plugin that we're going to check out today are the virtual production utilities. So I have those three plugins turned on in my project already. So project settings, let's go ahead and talk about a few really important ones. So we'll bring up the project settings editor. And the first one that you want to turn on is ray tracing. So we'll just search for ray, and you can see that I already have ray tracing turned on. It's worth mentioning that many of these project settings require an engine restart. So I've already turned them on just to speed the demo up. Now, for ray tracing to work, you also need to enable DX12. So that's done by going to Platforms and selecting Windows, going to the default RHI and just selecting DX12, which I obviously already have done also. So with that done, let's go ahead and search for exposure. So there's a few exposure settings that you want to make sure are turned on, and depending on how you created the project or when you created the project, these may or may not be turned on. So it's a good idea to turn on extended default luminance range as well as the apply pre-exposure. The next project setting that I always change is the reflection capture resolution. And I always increase this to 1024 or 2048. And you might be saying, well, we're talking about ray tracing. Why do we care about reflection capture resolution? And it's actually really important because Unreal uses a hybrid ray tracing approach. What this means is you may, for performance, ask Unreal at a certain point to not trace a ray and to fall back to those reflection captures. So you're going to want to use best practices when setting up those reflection captures, and part of that is increasing the resolution to get good visual fidelity. And we'll be talking about reflection captures a bit more later in the presentation. So the next project setting that I turn on is the Enable Clear Coat Second Normal, and this one is really, really important. Let me show you an example of what this does. So here what we're looking at is the dash of the Audi, and I've used the Automotive Material Pack carbon fiber on this main gray bar, and it doesn't look like carbon fiber at all. And the reason it doesn't look like carbon fiber is in this render, Enable Clear Coat Second Normal is not turned on. So we don't get any sense of that weave happening underneath the clear coat. So let me show you an example of what it looks like once that flag has been enabled. So here we can see we get that normal information in the base substrate, giving us the weave with this beautiful clear coat layered on top of it. So the takeaway from this is if you're using the Automotive Material Pack and you're doing anything fancy with normals and clear coat, you want to make sure that's just turned on. So the next one that we want to talk about is atmosphere. There's several different project settings for atmosphere, and the atmosphere model was newly introduced into Unreal. It's amazing. You want to make sure these are all turned on, including the effect height fog. So if you look at my scene, let's go ahead and close this down here. In my sun sky, you can see the sun sky is made up of the calculator for the compass, skylight, a direction light, as well as the sky atmosphere, which is actually driving all the color and the gradient that we see in the background. Now, I just added this to my scene by dragging it in from my lights. It's also worth noting that I have a post-process volume in here. This is just the default post-process volume. And I've got an exponential height fog also dragged in. Now, because I had that exponential height fog atmosphere switch turned on, the sky atmosphere has the ability to actually drive the scatter color of the exponential height fog. So you're going to want to make sure that you turn off any other additional contribution. You want to basically make the scatter colors black on that exponential height fog so that all the color information is being driven from that sky atmosphere model. That's just, that's basically it. So you can see as I change my solar time here, the background gradient changes because it's being generated by that sky atmosphere. All the lighting information changes, and it looks pretty good. But what you may notice is the reflections look super, super soft, and you might think maybe it's not ray tracing. No, it actually is ray tracing. The reflections look really soft because of that important console variable that I said is like the first thing you want to turn on, basically. What's going on is the denoiser is softening those reflections. So we want to disable the denoiser. So how do you do that? It's super, super simple. To enable a console variable, all you have to do is hit the tilde key, and that brings up the command window down here at the bottom. So all I have to do is start searching for denoiser, and you can see that there is a reflection denoiser. Now this is a Boolean, so it's just a 0 or a 1 to turn it off. So what we want to do is we want to turn the denoiser off. And as soon as I do that, you can see my reflections got nice and crisp. Now it looks like it's ray tracing, which is exactly what we want. Now here's a cool trick when working with console variables. If I hit the tilde key one more time to bring it up, I can use the up and down arrow keys to jump through the last console variables that I've set. And you can see that I've played around with a few of these in this project. So if I wanted to turn that denoiser back on, all I have to do is, kind of arrow up to it and set it to a 1 state. And you can see now we have those super soft reflections. So let's just go ahead and get that turned back off. The next issue that I want to show you guys how to resolve is bad reflections due to low precision normals. So look at the reflection of this color calibrator in the door of the vehicle as I start to move it across the screen. You're going to see all this weird swimming and kind of waviness happening in the reflection of that color calibrator in the door. Also, if we zoom in, you're going to see a lot of this kind of stair-stepping and just really bad artifacting happening across that reflection. So there's a couple of areas where you will need to go to address this, or potentially need to go to address this. And first is in the project settings. So in project settings, just search for buffer and go down to the gbuffer format. And what we want to do is we want to change this gbuffer from default to use high precision normals. So as soon as I do that, you can see all those gradients, they just clean themselves up, and we're not getting that weird stair-stepping anymore. And I'll turn it back off just one more time so you can see, it just looks really bad, really gnarly. You put on the high quality normals and it just cleans it up. So let's jump back out to the reflection on the door, and I'll start to move the car across the screen here. And you'll notice that even though our gbuffer has been set correctly, the door still has an issue. And the reason that's happening is because on the geometry level, there's actually an attribute that you may or may not need to turn on. So let's go ahead and bring up the static mesh editor for this door and check that out. So in the door, you can see there is another attribute for high precision tangents, and you want to make sure that this is checked on or turned on. Now, depending on how you imported the geometry, this will be on or off. So if you come in from FBX, that's probably not going to be on. But if you bring your geometry in through Datasmith, this high precision tangent basis is going to be turned on by default. So just keep that in mind. So you need to do two things. You need to turn it on, and then you need to click the apply changes. So now that we've done that, as we start to move across the screen here, you can see that that color calibrator is no longer swimming and doing, that really weird wavy pattern. So it just really goes in there and totally cleans up all the reflections for you and makes them look correct. All right, so with all the setup work done, the next thing that we're going to do is start to improve the look of the vehicle. And I want to work on the headlights. So they're really dark. We're going to use some of the attributes that the ray tracer has to fix that. So let's go ahead and jump into the post-process volume, and we're going to go to the ray trace reflections, and the max bounce we're going to increase from 1 up to 3. And as soon as I do that, you can see there's a bit more sparkle in the headlights, and there's reflections of reflections kind of happening across the vehicle, but it's still kind of dark. So to fix that, we're going to use a CVAR that's going to allow us to have, after this last bounce, the ray tracer, instead of falling back to black, actually go out and sample the reflection captures. So if I hit the tilde key and use my up arrow to scroll through my list of recent commands, you can see that I have in this list raytracing.reflections.reflection capture, and it's a Boolean, so 0 and 1 to turn it on and off. So as soon as I turn that on, instead of falling back to black, we're going to go out and sample that reflection probe that's basically part of the skylight. So it's going to sample the sky color, and that looks a whole lot better. So the next thing that we want to change is the way the glass is being calculated. So if we open translucency, you can see that it's using a raster model. We're going to switch this over to ray tracing, and this is going to make the glass look a lot more realistic, especially if we have a more complex environment for it to reflect. So how do you get a more complex environment? It's actually really simple to do using the HDRI backdrop. So let's go ahead and turn off our sun sky, and let's drop into our level an HDRI backdrop to begin lighting our scene. So with that dropped in, let's go ahead and lower it so that it's a bit lower than the parking lot. And let's increase its brightness by dropping down my EV to something like a -0.5. And you can see that this starts to look, pretty good. Now, this is a pretty diffuse image. If you had a higher contrast image, something like a night scene with streetlights or a sunny sky without any clouds, you probably will need to change some attributes on the HDRI backdrop to capture that high contrast. So let me show you what that means in context. Let's go ahead and change this image over to something with a bit more contrast. So this is just another sample image that comes with Unreal. And I'm going to go ahead and just make this a little bit brighter. So we'll just -1.2 or something like that. And you can see that it's, it's just, sunny day, no clouds, lots of contrast, and we're picking up the directionality of that sun, but this shadow is a little soft, and you can really see that, especially if I turn on lighting only. So we want to crispen that shadow up, and that's pretty simple to do by just changing one of the attributes on the HDRI backdrop in the skylight. So there's a component, and in that component is a skylight, and what we want to do is we just need to increase that cube map resolution. So if we go from 128 up to 1024, you can see that that shadow is now nice and crisp. So let's go ahead and kind of pan back over here and drop down. So that's looking a lot better. So the next thing that I want to talk about with this skylight is an attribute that you're probably going to want to play around with and fine tune. So it's the amount of samples per pixel that the ray tracer is using to ray trace that skylight. So I'm going to turn on my frames per second here, and let's just grab that skylight again. And you can see that we're right around 10 milliseconds. Let's just do something like that so it's a little easier to see. And if I increase the samples per pixel, this is going to decrease noise. So if you have noise coming from the skylight, you're going to need to crank the samples up, but it's going to come at a cost. So if we go up to 16 samples, we've added about 7 or 8 milliseconds to the scene. So this is going to be a parameter that you're really going to be balancing to try to find that visual fidelity versus frame rate that suits your needs. So just keep in mind that this is going to be one that's going to be kind of scene specific and honestly image specific when you're kind of playing around with it. So that looks pretty cool. And with that done, the next thing that we want to do is let's go ahead and get another HDRI image in here. And this time an image that, it's actually the image that we used in that initial video that I used for the overall beach scene. All right, so let's go ahead and jump back up to the root of that HDRI backdrop and map into it a new image. And again, it's going to be the image that was used in that initial video. So it's going to be the beach image that this environment was designed to go with. And one thing that I want to draw your attention to is when you bring in your own HDRIs, there's a few things that you want to double check. First, make sure that sRGB is turned off. You also want to make sure that there are no MIP maps being generated for it. And you may want to increase the maximum resolution and make sure that you turn off MIP maps before you say increase maximum resolution, because that means it doesn't have to make all the MIPs going down, which is going to make things just a lot faster. So just kind of keep that in mind when you're working with your own HDRI images. So with that done, this image comes in and it looks pretty cool, but there's a few things that I want to change. First of all, the scale of it's a bit wrong. The ocean's kind of come in onto the parking lot and the buildings don't look like they're going far enough away. So we're going to modify a few of the other attributes on that HDRI. We're just going to increase the size of the actual dome that it's applied to. And I'm also going to change that projection. So I'm going to increase the Z value of this projection. So you could do that manually, just by dragging on it, or you can kind of come down here and just manually pop in a number. So I'm just going to push that back out a little bit so that the beach kind of happens after the parking lot. So with that done, the next thing that I want to do is I want to start to really try to fine tune the overall lighting balance of my scene, because it's kind of bright right now. So I'm going to go and set my EV to 0 just to see what happens with that HDRI image. And this actually gives me a pretty good understanding of what's happening here. I mean, this image, I think at 0 actually has a lot of detail in it. It's probably a little underexposed right now, but I'm going to set everything up with it at a value of 0. So you'll notice that the environment feels really dark, especially when you look at the backside of this building versus the backside of this walkway. So what we want to do is we want to increase the amount of intensity that the skylight has. So we'll just go highlight that skylight, and I'm going to go ahead and push this up to a value of 2. An intensity value of 2. And as soon as I do that, you can see that this feels a bit better. Now, it's still not exactly what I want. I really want to have a strong sun kind of burning off of that spot right there. And this is still feeling, it's got a little bit of directionality to it, but it feels really, really soft. So often when I'm working with image-based lighting and the HDRI backdrop, I'm going to go in there and I'm going to add in a sunlight. I'm going to add a directional that's going to give me, that level of control that I want. So let's go ahead and do that now. So with the directional light added into my scene, I'm going to want to do a few things here. So let's go ahead and display that light really quickly. Just say show lights underneath our sprites. So this light, obviously I want to kind of rotate around so that it's sort of, shooting and getting in that general area of our environment. And an easy way of sort of lining these guys up, honestly, is let's just translate this light sort of down here. And I'm just going to spin this around a little bit so that chrome ball is sort of out there. And what I'm going to do is I'm going to just drop down the overall intensity of this in scene, just something like that, and try to make sure that my light actually looks like I got it pretty good. That light, I might want to rotate it this way a little bit more, but I just kind of want to get that sun sort of hanging out, just kind of peeking over that, and that looks pretty good. So let's go ahead and put this back down to a value of 0, and yeah, that looks nice. So we've got this light kind of coming across here. Now the next thing that I'm going to do is I'm going to start to change a few attributes on this light. So number 1, we're going to want to go ahead and set it to movable. And we're also going to come in here and we're going to turn on a few things. So there's an atmosphere already in my scene. You can see the sky atmosphere. I want that sunlight to get affected by that. I want its color to be driven by that. So if I just search for sun and I turn on that, you can see it just added the warmth into the light. Now, if I wanted to overdrive the warmth, beyond what that sun atmosphere is adding in, you can do that, right? Like you could go in here and you could say, you know what, I'm still going to use a temperature and I'm going to put this to 5,200. And you could still use that, even if I put this down just to really overdrive it, something like 3000, you can see that you can push more warmth into it if you wanted to layer those two together. So keep that in mind. So the next thing that I want to do with this light is I also want to increase that source angle. I want to have softer shadow. So I'm just going to put that to like a value of 2. And I might actually lower this down a little bit more, something kind of like that. And I may also want to give it a little bit of source angle. So if we look at the paint on this vehicle here, right now the paint is basically, I have all the bells and whistles turned off. So I'm going to just give this a little bit of source angle. You're going to see it's going to increase the size of that sun ever so slightly. Now, I want to start to fine tune a few things on this paint. Because like I said before, basically everything is turned off as far as orange peel and scratches and metal flakes. So what we're going to do is we're just going to kind of dive back in here, jump into the car paint, and I'm going to turn on a few of the attributes for this. So number 1, I'm going to go down and I'm going to give it some max roughness. So the default values on this is 0.4 and 0.8. And what that does is it actually, I feel like it kind of softens the image a little bit more than what I want. So I like to drop that max roughness down to something like 0.01 or 0.02, and that really crispens it back up on those glancing angles. But if I still want to get some of those scratches in there, I can put this up to something like 0.12 and on that max rough. And now as this kind of moves across here, you're going to get this sense of these little, let's just increase that up to something like 0.3. You can see now there's a little bit happening as it moves across this surface, and that might be a little bit strong. Let's go back down to something like 0.2, or maybe, the car was just detailed. We'll make it 0.15. But, you get this little bit of breakup on that speck, which looks really, really, kind of nice. So the next thing that we want to do is let's get some metal flake on there. So I'll just turn the flakes back on so you can see there's a subtle little bit of metal flake happening inside of that guy. And then the orange peel, I also had zeroed out. I had all this stuff turned off because when we were looking at that early reflection issue, I just wanted to have it super, super clean. So we're actually going to introduce back in some waves. So we spent all that time modifying those normals so that they didn't wave. And I'm going to use the orange peel to actually introduce back in a little bit of wave. So as I turn that on, you can see we had this subtle little, orange peel detail. And I think that's probably a little bit strong. I'm going to go 0.03. So with that done, our car is now got some pretty nice looking paint. We've got this directional light in the scene. Everything's starting to look a bit better to me. Now, there's a couple of other things that we want to start to talk about, and that is reflections and the hybrid ray tracer. So we kind of alluded to that a bit earlier, and we never really finished the conversation. So if you look at this right now, things are looking good, but this wheel feels really, really off, right? So right now what's happening is with the hybrid ray tracer, the default max roughness value in the post-process volume is set to 0.6, okay? So what that means is any pixel that's got a roughness value lower than 0.6, which honestly is the majority of pixels in my scene currently, are going to use the ray tracer to calculate the reflection. And any value that is above 0.6, or any material that has a value, or any pixel that has a value above 0.6, is going to kick back and use the reflection captures to calculate what that reflection should look like. So that's what's happening on the wheels, is it's using the reflection captures, and that doesn't really look realistic. So the cool thing about this is it really does let you fine tune the visual fidelity versus performance, because in lots of examples, you're not worried about maximum frame rate. You might be creating an EXR image sequence or a giant still, and you just want the maximum quality, and you can get that by just setting your max roughness to a value of 1. We're now ray tracing every single pixel regardless of how rough the surface is. And it looks cool. And it costs us like 4 milliseconds to do that, but it also introduced in some noise. So if you wanted to clean the noise up, you'd have to start to increase your sample. So if we go up to 5 samples per pixel, it cleans up the noise a bit, but we're around 40 milliseconds now, right? So that's not good. So let's just drop this back down to 0.6, and let's try to make it look a little bit better with reflection captures. So why is it bright? Well, the reason it's so bright is right now there's only one reflection capture in my scene. It's that sky that was a part of the HDRI backdrop. So it's basically falling back to the sky color. So what we want to do is we want to add in some reflection captures that are going to better capture the overall environment. And I've already set a lot of those up in my scene. So let's just go ahead and turn those guys on. And if we kind of zoom out here, you can see I've got a big one going down the side. I've got one on the hood. I've got, little spheres over in these nooks and crannies on the headlights. And then wrapped around each wheel, I've actually got a reflection capture sort of centered on the wheel. And what I'm going to do is I'm actually going to go in and I'm going to push off where that reflection capture is actually going to get rendered from, that spherical reflection capture. I want to push out a little bit from those wheels so that it actually gets a bit of the environment in there. So what we're going to do now is we're going to go ahead and we're going to build the reflection captures. And what's going to happen is it's going to surprise you. So we hit build, it goes through, it calculates all of these reflection captures, and boom, nothing changed. What the heck? Why did anything change? If I grab this reflection capture, normally if you start offsetting one of these guys, you'd see the reflection moving around. So the reason nothing happened is because of an issue with the way the HDRI backdrop comes in. So how do you fix it and what is the issue? So let's go ahead and select that HDR backdrop actor and grab this skylight, and you'll notice that there's a parameter called sky distance threshold, and it's set to 1. Incorrectly, I should say, it's set to 1. If we drag a normal skylight out, you can see that sky distance threshold is set to a value of 15,000. What that value does is it measures from the point of that skylight out in units, and anything that's within that, lower than that range is going to be considered part of the sky. So at a value of 1, basically all of my geometry in my scene is part of the skylight. So it doesn't, the reflection captures never work. They don't get evaluated at all. They don't even get calculated. So what we need to do is we just need to increase that up to something like a value of 6,000, something like that. And then we're going to go ahead and we're going to say build reflection captures one more time. And once we do that, you can see just like that, now it looks a whole lot better. It gives you the result that you would expect. And of course, if I grab this and start moving it, you can see that's that reflection capture offsetting on that wheel. So if we go back into our post-process volume here, and we grab this guy and we just look at what's going on, you can see that at a value of 0.6, it looks pretty similar to what it looked like at 1. If I put this up to a value of 1, they look almost the same. And if I go down to something, but the frame rate's bad. Like, look, my 42 milliseconds. So if I put this back down to something like 0.6, the tire gets a little bit brighter, and that's mainly because this reflection capture is not really covering that tire quite as much as it probably should be. But the wheel and the brake actually look good, and we're back down to 20 milliseconds. So that is why you need to still work with best practices when you're using the hybrid ray tracer. You still need to do best practices for your reflection captures and reflection probes and things like that, so that when they kick back to them, they look super cool. And the end result now is, something that looks, really, really sweet. So the next thing that we want to do is we want to basically sweeten the lighting a little bit. It looks a little bit off to me. So I want to get a little bit more punch in this, and it's kind of washed out underneath the car. So I'm going to use the color correction volume that's part of the virtual production utilities. So make sure your view plugin content is on, and come over to your search path and just search for CCV. Jump into that folder and drag out the blueprint color correction volume. So with that added to our level, you can see that it's actually casting shadows into the environment. So let's go ahead and search for hidden, and let's just hide this actor in the game so that those shadows do not show up. So even though it's hidden, the color correction still works. So you can see as I move this gain around, I can still start to introduce a level of color correction. So all we really need to do is just drop this down. Now I'm going to switch the shape of this. Instead of being a sphere, I want it to go ahead and become a box. And I'm going to just kind of increase the scale of this guy. What I want to do is ultimately, I want to have this color correction volume just be a small sliver that's going to sit underneath the car to really make it feel planted or grounded. So I'm going to increase the level of the outer value here just to kind of blow that up a little bit and give it a little bit more fall off. And I'm just going to now position that underneath the car. And by doing this, you can see that it just kind of starts to make it feel a bit more planted underneath the underneath that car, and I think it just looks a little bit nicer. So now that we've done that, the next thing that I want to do is modify a couple of attributes in the post-process volume to give this a bit more punch. It still feels a little flat to me. So let's go ahead and pull up the post-process volume. And the first thing that I'm going to do is I'm going to change the bloom model. So instead of using the standard bloom for automotive stuff, I always like to switch over to the convolution, and that's going to give it this really nice little kind of star effect where the sun's hitting. And this does cost a few milliseconds, but I feel like it's really worth it because that overall little bloom that you get just looks so nice and so realistic. So the next thing that I want to do is I want to add a little more kind of punch to this. So I want to make it a little more contrasty, and an easy way to do that is with a LUT. So I'm going to go down to the color grading into the miscellaneous, and we're just going to add onto this a color LUT. And if I just search for LUT, Unreal ships with a couple, so I'm going to grab the LUT Afternoon, and that's a little bit strong. I don't want quite that extreme of an effect, so I'm just going to drop down the intensity of that LUT to a value of 0.2, and you can see now, let's go ahead and just hide all that. You can see now that we've got something that's starting to look really pretty nice. So let's close that down and jump into our camera sequence. So this is what the end result ends up looking like. And what I want to do is I want to output a couple of these clips using the new Movie Render Queue. So go to the Windows, Cinematics, Movie Render Queue. And inside of here, we can use the Movie Render Queue to do a couple things. It can be used to generate extremely high resolution stills with a tiled rendering workflow, or it can be used to render out sequences, multiple sequences kind of stacked up on top or queued up on top of each other. And the rendering will render out sequences of images that have the ability to have multi-frame anti-aliasing as well as multi-frame motion blur. So I'm just going to click the plus button to add in a couple of cues here. So we'll just go and we'll grab, we'll just grab this first one. We'll just grab the Auto Master, and I'm going to add onto that this back turn. So once you've added a couple of sequences, the next thing to do is to set up the options that you want for the output. So you can make your own custom output options by selecting from a variety of different attributes, or you can use a preset and save your own presets actually. So these are two presets that I made. We'll just bring on the motion blur. So motion blur is going to be a PNG sequence with the anti-aliasing set to do 5 spatial samples and 3 temporal or motion blur samples. And I'm turning off the temporal anti-aliasing because of the count of samples that I have here, which is pretty awesome. And then for the output, I'm basically going to render out just a 1920 by 1080 image. So pretty straightforward stuff there. So with that done, we'll go ahead and we'll say accept. I'm going to do the same thing for this. We'll apply the motion blur setting. We'll say accept, and I'll just go ahead and fire off a render. So it's going to render out both sets of camera sequences, which is really pretty awesome. So I'd like to thank you guys for taking the time to watch my seminar. I hope you guys enjoyed it. We were moving through stuff really quickly. I know that a half hour is not a lot of time to talk about some of these concepts, but I hope you guys enjoyed it, and thanks again for taking the time to check it out. Cheers, everybody.